Okay, on this one, we've got a function, x squared e to the 10x. They want us to find three important intervals where a and b are critical numbers. So we got to take that function, bring it down here, I guess. X squared e to the 10x, and we got to differentiate. That's how we find critical numbers, right? Derivatives equal to zero or infinity. So this is the product rule because we've got two functions of x multiplied. Take turns. First one goes 2x. Second one, whoops, stays unchanged. It's not his turn. Plus, the first one stays unchanged, not his turn. And now it's the second one's turn. How do you do derivative e to the 10x? He's our favorite derivative. I'm just kind of getting in the way here. He's our favorite derivative. He doesn't do anything. He just stays the same. But since the inside is not a simple x, you're going to go time. The chain rule says times root of the inside, which is 10. Do you see that? So when you take the derivative of e to the 10x, he doesn't do anything. He's our favorite derivative. So he just stays the same, keeping the inside the same at first. But because the inside is not a simple x, chain rule says now multiply by the derivative of the inside. Derivative of 10x is 10. So there we go. There's the derivative. Let me clean that up a little bit. So that's 2x e to the 10x plus, I'll stick the 10 in the front. It's getting a little sloppy there. 10x squared e to the 10x. There we go. That's the derivative. Now, we have to set it equal to zero because we got to find out critical values. So as you look at this, you should factor. What can you take out? 2x e to the 10x in a big old bracket. 1 plus 5x. Do you see that? Because I have to multiply 2x e to the 10x times 1, just go back. And then this, 2 times 5 be 10, x squared, right? X times x squared, e to the 10x. There it is. Okay, so now we set each part equal to 0. 2x e to the 10x equals 0. Or 1 plus 5x equals 0, right? That's logical. If two things are multiplying to equal 0, either one could be 0 to make that true. How do you finish solving here? Well, did you know this part, the answer is just 0 here. Can I just do that by looking at it? There's no way e to the 10x cannot ever be 0. Are you aware of that? If you're not, you need to spend some time thinking about that. Let me show you. You do e to a positive number, it's going to be positive. You do e to 0, it's 1. You do e to a negative, like -2, it's just going to be 1 over e to the second. It's still going to be some positive thing. It's never 0, it's never negative. Do you realize that? E to a power, if you let that power be positive, it's just going to be positive. Let it be 0. E to the 0, anything to the 0 power is 1, positive 1. Even if you make it negative power, a negative power is 1 over 1 over. Remember, negative powers don't mean negative in the front. They mean flip it, and it's still positive. So there's no way this guy's ever going to be 0. The only way this expression will be 0 is if x itself is 0. So there we go. And then bump this over. So 5x is -1. Divide by 5. Boom, -1/5. I'll make that -0.2 decimal. Okay, so now, there we go. There's the two answers in order. They want the lower one first, A first, then B. Okay, now they want you to do the intervals where it's increasing, decreasing. Well, you know that means f prime positive for increasing, f prime negative for decreasing. So I got to check on the number line thing. So I'm going to go, okay. Let's go to the number line, put these things on there. So we're going to have one here, one there. Get rid of this, get rid of this. So we're going to have x is -0.2 and x is 0. And we need to check between them. So I'm going to come over here and check. This would be something like -1 to check that left interval. This will be, what's something between 0 and -0.2? It'd be like -0.1. And then over here, x is 1. Check that. Okay. Check what? Check the first derivative, which is, well, you can use this version, if you want, or this version, either one, whatever. I'll just grab that first one, I guess. So I'm gonna check. prime equals, what was that first version? Um, 2x e to the 10x, 2x e to the 10x, plus 10x squared e to the 10x, plus 10x squared e to the 10x. Like I said, if you prefer, you could do this one. It's the same thing because they're equivalent, right? This, if you multiplied this one out, boom, boom, it's the same as that one. So either one, you can plug in either one. It'll work good. I don't think anyone's really easier than the other. They're about the same. So I have prime. So I'm going to plug in. What am I plugging in? I'm going to plug in -1 first off into that. Let's see. Yeah, I got it. So there it is. I've already typed it into Desmos. Plugged in -1. Look at my answer, 3.63 times 10 to the minus 4. 3.63 times 10 to the minus 4. What does that minus power mean? That means the decimal goes back 4 places. 1, 2, 3, 4, and those bring in zeros. So it's 0.000363. I really don't care about that. I just care it's positive. Don't be thrown off by that negative power. That doesn't mean the answer is negative. That means the decimal needs to go left 4 places. It's just a really tiny but positive number. And so now let's try the middle. Plug in -0.1. So instead of, wait, let me make sure. All those places that are -1 got to become -0.1 now. Okay. Point, point one, point one, point one. There we go. I got -0.036. -0.036. -0.036. So it's negative. And finally, x equals +1. Let's plug in +1. All those guys got to become +1. Here we go. 264,317. That's big. 264,317. It's positive. That's all I care about. So it looks like our answers are positive. So that's increasing. So this is an increasing section, negative, decreasing, positive, increasing. So increasing, decreasing, increasing. So increasing, decreasing, increasing. And so there we go.